How do you know that?
Because SnapMap gives me, Snapchat
Oh,
gives
it
me
gives
like,
you like
here
a
goes today.
Ah, okay. What were we learning about?
I don't know, I don't
Probably
get
how you
glasses.
Probably how you made it when we were learning about like DNA stuff.
I was definitely failing. Whichever thing
Okay.
it was.
She's gonna launch the water balloon straight out from her house. So this is the house, and she's gonna go like that, right? And the house is 12 meters high. Vertically, the initial velocity is 0. So what happens to VIT? It's gone. 0 times whatever time it is 0. So we're left with d equals half at squared. How do we get rid of the half? Times by 2. That's going to get rid of the half. So we put 2 there. How do you get rid of the a? Divide by a. Divide by a. How do you get rid of the square? Square root. I'm going to square root what's left here because these are all gone. And so I have to square root that whole thing. So this might be something that if you want to save a bit of time on a test or a quiz, you might remember that for vertical, 2 times d, and I'll say dy to just say this is the y displacement, not the other displacement, over a, which in this case is going to be negative 9.8, right? Most of the time this is gravity, is equal to the time vertically. So for us, that's 2 times 12, negative 12, because we're going down, over minus 9.8. So that gets rid of that negative square root problem. What happens if you have a square root with a negative inside of it?
No,
There's a problem there, right? You can't do that. You can't do it unless you know imaginary numbers. So this is about, what did we say, 1.5?
1.56.
1.5 seconds. Okay. So that's how you find the time. Maybe we'll do the next thing too on the video.
Wait, why is it?
Oops. Okay, so the next question is, how far forward will it travel? So we know from the last one our time is 1.5 seconds. How far, so remember the house, she's up here, she's launching it like this. That's bad. What's our displacement x, y? So sometimes we call this the range. Are we going to need any of these for this? A. Penta? V equals d over t, right? So the x velocity, which in the beginning we only have x velocity, is the x displacement over time. But in this case, we don't actually want the velocity, right? So we need the d. And because we know our initial velocity, so we're going to change this now to vxt equals dx. And so if we put our numbers in there, we shoot it at 25 meters per second times our time of 1.5. 37.5? Something like that?
Yeah, 37.5.
25 times 1.5 is 37.5.
And so that would be your range, how far the object goes. Okay. That's your